Hey everybody, this is our lesson on Newton's third law of motion. So we learned the first two. Now we should be able to finish out this objective of being able to explain all the forces. So Newton's third law of motion states that to every action there should be an equal and opposite reaction. So as you see here, the force is applied by the extinguisher on Bart, and then that's what causes the chair to shoot back as well. This also applies second law of motion because he's accelerating in the direction of the force. So this describes action-reaction pairs, so two forces that have equal strength but in opposite directions. When one object exerts a force on a second object, the second object exerts a force on the first object in equal but opposite direction. So think about when you, how do I want to say this? If you push against an object and the object does not move, that means it has an equal but opposite force back on you. So if you're not moving and the object's not moving and you're at a stalemate, that is Newton's third law. However, in a lot of cases, one side will exert more of a force than the other. These forces may be equal but not balanced. So like if you've ever been in a canoe or a kayak, you would know this. So when you paddle, you're applying a force to the water. The water is actually applying a force back. You just happen to be applying more of a force, which is what allows you to propel in the direction that you're trying to go. And that's all due to momentum. So momentum is defined as a property due to the mass and velocity of an object. And the formula for momentum is momentum is equal to mass times velocity. This is represented as P is equal to mv. P, for some reason, is the letter for momentum. I really couldn't explain to you why. So the unit for momentum is kilogram times meter per second. And this will not change unless the mass, velocity, or both of them change. So the momentum should stay pretty constant. And it can be transferred from one object to another. So you can think of like car crashes here. Think of if you're playing pool, and if you're good at playing pool and you hit a ball with the cue ball, the white ball should stop completely and the next ball should be the one that moves. That means you transferred your momentum, all of it, from the cue ball to whatever you hit. And we do have a law of conservation here for momentum, and it states that the total amount of momentum of a group of objects does not change unless acted upon by force. So the amount of momentum present should be the same unless some outside force is applied to cause a change. Just ignore that part. Okay, so let's look at an example to calculate momentum. So this says if an object with a mass of 12 kilograms is moving at 10 meters per second, what is the momentum? So our formula is P is equal to mv. Our m is 12 kilograms. Our v is 10 meters per second. So we're just going to multiply those together. And we're going to come out with 120 kilograms times meter per second. So remember, this one is not with acceleration, so this is not a Newton. Okay, so this is not a Newton. This is kilogram times meter per second, so do not forget that unit. So go ahead really quick, pause the video and try this example. Let me cut my camera off. All right, guys, so you should be able to, from here, you should be able to calculate momentum and understand all three of Newton's laws.